President Cavaco Silva, Prime Minister Socrates, Dr. Beleza, Dr. Summers, members of the Champalimaud family and foundation, members of the jury, and honored guests. Dr. Yao and I are deeply grateful to you for your warm hospitality and for your decision to honor us with this year's Champalimaud Prize. For me, it is also a special honor to share this award with my good friend and colleague, Kingwei Yao. Before proceeding further, I would like to apologize for my inability to deliver these remarks in Portuguese. I'm sure that if I attempted to do that, it would be both difficult for the speaker and painful for the listeners. This event marks the second year in which the Champalimaud Foundation has focused international attention on innovative vision research and clinical ophthalmology. In an era of increasingly tight government funding for biomedical research, the Champalimaud Foundation's bold initiative to identify and support the most creative vision research will have an impact far beyond the direct recipients of this award. This kind of support challenges all scientists and physicians to dream the big dreams. I salute the Champalimaud family and the Foundation for your wisdom and your generosity. Vision is a most remarkable sense. It can provide information about objects that are just centimeters away, as when we thread a sewing needle, or that are trillions of kilometers away when we look up at the stars. Our visual system can capture movements occurring in less than 1/10 of a second, and it can operate effectively on moonless nights and sunny afternoons, environments that differ by over 1 million-fold in light intensity. My particular contribution to vision research has been first the identification of the pigment molecules within the eye that capture light and mediate our sense of color, and more recently the discovery of some of the ways in which genes control eye development and contribute to inherited eye disease. We can date the origin of modern research on human color vision to the year 1665, when Isaac Newton, then a 22-year-old student at Cambridge University, drilled a small hole in his wooden window shutter and placed a glass prism in the narrow beam of sunlight that entered the room. The result was a beautiful rainbow of colors, with each colored ray of light exhibiting its own distinctive angle of refraction as it passed through the prism. In the months that followed, Newton proceeded to systematically explore the appearance of various combinations of these colored lights, thereby providing the first quantitative analysis of human color perception. In the nearly 350 years since this remarkable series of experiments, we have learned that human color vision is mediated by 3 distinct types of light-sensing pigments, and that these pigments are present within a corresponding set of 3 types of sensing cells within the eye. We have also learned that approximately 1 in 50 men has a severe defect in color vision, and that approximately 1 in 15 men has a milder defect in color vision. By contrast, only about 1 in 100 women has a color vision defect, and in almost every case, these defects are inherited. In this particular area, my contribution, and that of my coworkers, was the identification of the genes that code for the 3 types of light-sensing molecules that mediate human color vision, the determination of the structures of those molecules based on the sequences of their genes, and the use of those genes to produce and study the light-sensing molecules in the laboratory, and finally, the demonstration that alterations in these genes are responsible for inherited variations in human color vision. In our more recent studies, my coworkers and I have focused on the genes that control the development and function of the retina, the sheet of cells at the back of the eye that contains the primary light sensors. In this work, we have been strongly motivated by the plight of those individuals who have had the misfortune to inherit defective versions of these genes, and as a consequence, suffer from partial or complete vision loss. Indeed, a central goal of our work in this area is to obtain a detailed understanding of the pathophysiology of these eye diseases so that effective strategies for prevention and treatment can be developed. In closing, I would like to note that no scientific research occurs in isolation. Every scientist benefits from the wisdom of his or her teachers, colleagues, and students. We also benefit from the insights and the observations of scientists who preceded us. As Newton remarked in describing the debt he owed to the astronomers Galileo, Brahe, and Kepler, "If I have seen farther, it is because I stood on the shoulders of giants." In my own case, research is also a team effort, and the team's accomplishments come from the expertise, creativity, and hard work of students, technicians, and senior research staff. The Champalimaud Prize recognizes all of the members of that team. Thank you.